Yeah. Hello, Pankaj.
Hello.
Yeah.
Hi, sir. Yeah.
Yeah. Hello.
Shall we start, sir?
Yeah, just 2 minutes.
Okay, okay, no problem. Yeah.
Yeah. I have put a message on WhatsApp. People will join in. Sony madam, your screen
Okay.
is coming like a gray screen.
Yeah, I haven't shared yet. So when once you give a go ahead, I'll then start sharing.
Yeah, yeah. No, I'm telling to our ma'am, Sony madam.
Okay, okay, okay. Sorry. Yeah.
Sir, I'm seeing visible. You're not getting it?
No, no, I'm not getting it. Initially it was there, now it is not there. You reshare.
Sir,
Yeah, it has come.
Yeah.
okay.
Madam, you
Shall
go
I
ahead.
start?
So we start. Yeah, let's start.
Very good evening to one and all present here in this online meet. I, Professor Soni P. Bhambar, at Bharatiya Vidya Bhavan's Sardar Patel Institute of Technology, welcome you back day 6 of AICT sponsored 2-week third FDP on insights into intelligent automation, machine learning, and data science, where the theme is data science and its applications. I would like to welcome invited speaker for this session, Mr. Pankaj Sharma, who is Senior Software Engineer at Mphasis Ltd. Sir was with us during second FDP, but still I'll give a brief introduction of Sir to all of you. Mr. Pankaj Sharma is currently working as a Senior Software Engineer at Mphasis Ltd. He is a data scientist with an experience in executing data-driven solutions to increase efficiency, accuracy, and utility of internal data processing. He is experienced at creating data regression models using predictive data modeling and analyzing data mining algorithms to deliver insights and implement action-oriented solutions to complex business problems. He is a senior developer with more than 7 years of IT experience in developing and supporting the web-based entire architecture applications using PL/SQL HTML with jQuery. He has about 2.5 years of working experience on client side as an on-site coordinator with an onshore or offshore model on development and maintenance projects. He has strong database maintenance and development skills with extensive knowledge in creating and working with PLSQL packages, functions, and triggers. He has capability to explore, learn, and understand newer business domains and technology. Today, he will be taking a case study on object detection using CNN and its application in real time. Sir, may I now request you to take over and the session?
Yeah, thanks. Sorry. Thanks a lot. So yeah, so I have already given the link, collab link on the chat box. I assume everyone has opened that. Okay, so is my screen visible, sir?
Yes, sir, yes.
Yeah, okay. Thanks. Okay. Thanks, ma'am. Yeah. So let me know once anyone has got into the collab notebook and ready with that. So yeah, we have it ready, and who else do we have? It's a few more. Vismita, is it still baking? Okay. Okay, so who all are ready? Vismita, Vandana, I feel so yeah, 3, 4, at least 3, 4 of us are ready. Yeah, Indrajit. Yeah. Okay. So all are ready with this notebook. All right. So I believe you have already gone through CNN. You have been taught. I feel like I went through the course schedule and I could see you already have an idea of neural networks and CNN, RNN, and all those. So was there any example or any case taken for CNN? I mean, just a thought. I mean, I could see 2 sessions being done. So was any example taken at all? Any simple example? Okay, fashion means. All right. Okay, so you are fine with that. Good, good. So you may have an idea like what are the layers, and I don't need to start with like very basic definition of neural networks. Okay, so everyone should have at least some idea. All right. So in case of object detection, object detection in real time, so what we have is like real time video where we have different type of objects. Okay, so in that case, if you want to build a network, a neural network, or say algorithm that can identify the objects. Okay, so the first challenge which we have is getting the data set, right? Because then you need to, I mean, it will identify the object only when you tell what is the object, what's the name of that object, right? So that is biggest challenge to get the data for that. So because of that, I've used this CIFAR data set, which has like around 60,000 images of different objects, right? So what it has is it has a small images of each object, right? So it's 32 by 32 pixel, means it is small. So due to that, it is computationally easy for us to run the run the code as well, because it takes a time. It takes time when you run a neural network, right? So you must have known when you were doing MNIST, if in case you have run. So it takes time even on collab. Also make sure everyone selects GPU as a runtime. Can somebody confirm if they have selected GPU? Because else if we try to run, it will take more time. Okay, so Neil, sir, yeah, who else was there? Vista Vandana was also there. I think so. Yeah, just make sure you select GPU, and first 2 lines will give you info about that, like if their GPU is included and everything. So you just try to print, you should get something if you have GPU selected, right? So everyone gets this, just basic this info, GPU. All the information. Okay, this is just for reference purpose, but yeah, first line will give you GPU information. Okay, so we are fine with that, right? Okay, so coming back to our topic, which is object detection with CNN. So I mean, in terms of getting the real time example, it is very challenging to get those, because for training them you will need at least few thousands for training the image data set, right? So if so I've written few like what data set I have been using. So this was done by some Canadian institute, their research in their research, and then it has 60,000 data, and then these are the objects it has currently, right? So these are the categories of object it has, like airplane, automobile, a bird, a cat, deer, dog, a horse, ship, and a truck. So these are very smaller photographs, and it was for research purpose. So we can take advantage of this and try to check, say visualize how does it work, right? How can we try to do this detection or classification of object which we can see in an image, or in fact we can do in video, right? So everyone knows, right? We can do that for video as well, right? We can extract that video. We have to extract the video frame by frame and do that class. Hold on, I'll share it again, no problem. So in case of video, so first application is in images. Okay, so the next level, what happens is, if we are done with images, then we can go ahead and implement that in videos. So in video, what happens, it processes each frame and tries to apply the same algorithm which it is applying on an image. So it is, I mean, once the model is built, it has you just have to load it, and then it can predict like within less than a second. So in real time, you'll get the detection output in the video itself. So that is like the next level where you want to detect. So basic use case is in terms of like you have auto driven cars, right? So it needs to identify what are the near objects or how much near is it, right? So that is altogether a different uh, architecture. It is very complex architecture, but yeah, so this forms the basis. Like we have to identify the objects, and then basis on identification of an object, we can perform the operation, right? So okay, so coming back to this part, we have all the imports. So okay, so if you, so whosoever was not, who was it to who still not loaded the links? Okay, so Jinali, okay, so if, I'll wait for you as well. So once you get ready, we'll start to run the import first. So no problem. Any question on the data set, why we are trying to use, I mean, what is why we are using, or any other question until that, I mean, until everyone is on the same page. Yes, that is, you should see if you have GPU selected, otherwise you won't see. Okay, so yeah, so everyone is at this import segment. So only Jinali was just getting the link, and I think have you done? So we can then start. So we have total 60,000 is the total size, and then in this sorry, Dr. Chetan. So this CIFIR which we are using, it has got 60,000 images, out of which we are going to segregate 50,000 and 10,000. It has to be 50 and 10. I mean, that will be later on, but all right. So okay, so coming back to our code, so we'll just first try to run statement. You should not have any problem in running import. So I hope everyone is running as well along with me. So this is the part we are trying to do. Hopefully import, I mean, on collab you won't have any problem on import anytime. But on local, when you're trying to do, there would be a lot of these which may not be installed on your system. Like Keras, all the modules won't be there. Okay, but on collab this will always work. What images? Okay. When we run the second, okay, I think you have run the second one as well. So if we try to run the second one, so we can see what all data we are trying to load. What is the data we are trying to? So you can see there are small images of objects like truck or car, horse. The reason this is small, I mean, because we want to. This is just a case study. If we want to build like real time, we need a lot of computation, power, right? Because these are small images, we would be able to get the results in a matter of minutes. Otherwise, if the image is big, so you would need more computation, isn't it? Right? So everyone must be knowing the basics of what does an image consist of. Is it? I mean, I assume like it has got, if it is a color image, it has got RGB 3 matrix. I mean, if you represent an image in terms of numbers, I mean, right? The model or computer will understand image only as a number, 1 and 0, nothing else. So basically, image is a matrix. It's 3 by 3. It's a matrix of RGB, right? It has got 3 by 3 matrix of RGB. That's why you need a GPU. Normal CPU will not be able to hold that computation, right? So each pixel has got 3 values RGB, and which is represented by a matrix, 3 by 3 matrix. So yeah, so given this is smaller, so we'll have smaller data to process. Okay, so you can even print more of them if you make some changes here. So anyone try to print more? So it's subplot 3 rows, 3 column, and 0th place. So I think if we try to might just need to pyplot.show. Images. I mean, there was standard code, but yeah. Anyone tried? Okay. Yeah, I mean, it is a small data set. It's small pixel size, which small pixel sized images. But you can imagine even with this sort of image, our neural network will be able to identify it. So you can guess the understand how powerful it is, right? So so we got all the 12 images. All right. So now we'll just move on. It's only for but at least you can at least guess okay what it would be. There this would be a shape. This one would be a cat. Yeah. All right. So now coming to the part here. So what are we doing here? So this is going to load data. Like you have, I think even MNIST data set is also like in-house, right? So within that library itself. So similarly, you're just trying to load data is inbuilt method of this. So it just give you the data here, right? Then you are trying to convert it into a float. All right. So okay, if you try to see what is it giving? Always better to do this, right? So if I do this and then if I print, right? So these are, so this is what, if you print the shape, so this is basically, these are all images. 32 by 32 is a pixel size, and 3 means it has got RGB, 3 what is it, 3 vectors. So there is an R channel, B channel, G channel, D. If it would have been a grayscale, there would be only one, right? So if we have 50,000, so that clears. Someone was asking earlier, so how many training data? So we split. I mean, it has internally done that train test split in as 50,000 and 10,000. So if you see this 50,000 images, 32 by 32 pixels, and 3 is a channel. Okay, so if you print, just try to print, what does it give you? Like you would big numbers, right? Yes, correct. So these are big numbers, right? So I mean, you don't want, so if you have gone through like all those sessions, you always need to normalize your training data or the data you're trying to give to machine, because it is always going to perform mathematical operation. So there's no point giving it as it is. Okay, so that will take more time. Instead, we try to bring scale down a bit, right? So if you scale down, it is again a performance benefit, and also it capture more information, right? It will not try to benefit. Okay, so this is just try to show you what does it have. So X10 is this. What does Y10 have? Please always try to see what I mean. Just see, these are labels, 6, 9, and everything, right? So we know how many labels we have from here. So everyone knows labels, right? Labels means output variables. Features means input. So Y10 is done. So if we try to run this cell now, so this we know. So we are converting it to float because we want to perform division. This is all converting it into a float, then we are dividing it by 255 because the maximum value a pixel can have is 255. I hope I'm audible, right?
Yes, sir.
Okay, yeah. Because yeah, there I think was disconnected in between, so I don't know. All right, so okay, coming back to here, so we are trying to divide it by 255. The pixel can have maximum 255, whereas 0 to 255 maximum. 255 meaning white and 0 meaning black. So that's how it is. So then this is what we are doing here. So I'll not run, I'll just explain what is this. And then what we are trying to do is we are doing one hot encoding of the categorical because we don't want I mean that 1 0 to 9, the 9 being highest, right? It's a number, so it should not think 9, 9 doesn't mean it is on, it's a higher number, right? It should not consider it as a normal number. So one hot encoding which we I mean everyone should be doing by now. They should be used to it now, right? So I'll just run this for now. Okay, so now if you run xtrain, you can see now what data you get. And the shape will be same, right? So what will change now? If you see everything is reduced now. It's all 0 0.0 point, right? Make sense? So this everyone must have executed this cell and got number of classes at 10. Okay. Okay, great. So next comes the part where we will try to build. So now our data is ready, right? Our data is ready to, I mean, it's normalized and everything, right? So now we'll try to create an, what do you say, a model, right? So we start with a, say, sequential, because we want to apply. So we say sequential because we want to apply all the layers. These are layers, right? These are layer 1, layer 2, 3, this is 4, 5, and then this is, so this is input, right? And this is output, and all these are between hidden layers, right? So everyone knows that hidden layer, input, output. It should have one input, one output, and any number of. So I'm assuming everyone knows. So what we are doing here? So we are saying first layer is convolution 2D. So it's a two-dimensional matrix we're giving, and this is the number of pixels, and this is a shape like 32 by 32 is my pixel size, and RGB three vectors. So convolution means what? I mean, what do we mean by convolution? So whenever we have an image, so, so what is an image? Image is like, so this is say 1 pixel, let's say this is 1 pixel. So when we say convolution, so it's nothing but applying a filter. In terms of mathematics, we can say it's matrix multiplication basically. So by applying filter, what we do is we extract important features out of it, right? So by means of extracting important features means what we will be is, for example, this is the image, right? So if I apply a filter to if I apply a filter to get the edges, okay, so what I will get, I'll get the pixel values of all these edges. So resultant image will be a black image and this all only edges. So that is convolution. Convolution means extracting important features, right? Important features or the information which you want, right? So this is all same. If you see in terms of color, I mean, if color is same means RGB would be same. The numbers will be similar. Like then, when there is an edge, there would be a difference, right? So convolution means we are applying a filter. Convolution means applying of two functions. So you will be applying a filter on this image and extracting the information which you need or features which you need, right? So my first layer is convolution, and this is shape and activation. So if you know about neural networks, so we have got an input layer, input layer, then we have got hidden layer, and then output. So it has activation functions, different activation functions, right? Based on that, it will produce an output. So output can be, so this is only one. So this is one, consider one input layer, and hidden layer can be any, and then there is an output. So for each input, hidden layer will produce an output. It's basically like it has got a function, activation function, which will decide whether to provide an output, what output should be provided, right? So that is activation function. So we have got different activation functions. If you have gone through previous session, like ReLU, leaky ReLU, softmax, and everything, right? So basically, we have constructed this first layer, right? So this is one layer, and this batch normalization will normalize our is another layer. It doesn't do any sort of convolution. Convolution is important because we need to extract the features, and then all other like max pooling. Max pooling is basically reducing the size of the image and enhancing the features. The features which we extracted from the convolution layer, the max pooling layer is going to amplify basically. Amplify the feature and reduce the total overall size. So it's used in that way. So we have got one layer, this second layer, third layer, and this. So input we have got 32, right? This is the reason we have to have 32 here, right? And output should be number of labels. That's why I told number of classes, which is 10. So output, it should give one of the 10 outputs, right? Because it is a classification. The objects needs to be predicted, like either it is a car, horse, ship, truck, some one of that, right? So it is a sort of classification, right? Because object cannot be detected by its own. You need to know which object. It can detect only the object which you have trained it for, right? So this and this will remain fixed. This can be whatever you want. More than this, like 64, 128, 256, you can go on increasing to check, right? So we'll just run this now, right? So everyone everyone must have run this, although there is no output. So this is just creating the model and not even creating layers. right? Not compiling. So I think everyone must have done that. Great. Right. So this part, so I'm sure you must have gone through on your previous sessions. Again, I'll say. So then in this cell, we just post the layers, right? Now the another thing is hyperparameters. So epochs, learning rate, decay, and this is any guesses? What is this? SGD. What would that stand for? Yeah. All great. Yes, correct. So yes. So epochs means number of passes. Epochs means number of passes, number of times it will try to. For example, I've got 50,000 training data. Number of times it will try to go through that data again and again, right? Learning rate is how quick adjustment it is going to make for each error, right? So if you have known gradient descent, learning rate should not be too high, neither should it be too low, because if it is too high, you cannot converge. If it is too low, it will take too much time to converge. So this is the learning rate. So this is important. I mean, this I randomly picked 25 because from around 15 to 25, 30 is what manageable. Like it doesn't take much of a time, right? You can go ahead and make it 100 also. No issue with that. If you get better output, I mean, if you are not getting significant improvement between 25 and 100, so there is no point wasting the computation power, right? So I got good output 5. That's what I kept that. And learning rate can be 0, 1, or whatever you want. So and decay rate is nothing but epochs divided by that. So that will be your convergence. Right. So I've created this SGD, means gradient descent object, where I'm passing the learning rate. What learning rate should it be? Momentum. It is again a part of how quickly it should converge. Okay, and rest so false. So it's not needed actually. But yeah, it's mandatory. So these three. So we have just created this optimization parameter. Basically, you can say that, right? So now we'll just compile, and then we have to pass the loss. So there are different loss types in Keras, right? This is part of Keras. No. So basically, this is a categorical and multi-label classification, multi-class classification. If it would have been binary category, there's a binary one option as well. But most of the time, when there is multi-class classification, we normally use this. It has a good success rate, right? So that's why we use loss. And again, there is no fixed parameters which you can say we will always use this. It's always depending on your data, right? So you can change and check. It's up to you. There's nothing right here, right? So loss, I just added categorical cross entropy, optimizer, which is SGD, that is stochastic gradient descent, and metrics. And based on what that needs to be evaluated is accuracy. Accuracy is what we are looking for, right? So I've compiled this. If I say I'll compile this with these parameters, right? And then this will print my summary and this line. Now this line will do what? Will fit my model with the training data. So I've got X train, Y train, and then validation data too, so that it will automatically correct it, right? So I've got X test and Y test to validate it. Okay. And epochs, number of passes. Batch size means, okay, so now coming to batch size. Batch size means the number of batches your data will be divided. size of one batch. For example, it has got 50,000 or something, right? So your number of batches will be 50,000 by 64, right? So what it does is, for each batch, it tries to predict the data and checks the output, and if it finds the error, it automatically corrects itself. So basically, it checks about, like, you can say 50,000 by 64 into number of epochs. So this is the number of times it is trying to learn, right? So this is your batch size, number of batches. For each batch, it will try to correct itself. Okay, so it is not going to send every data, full data at a time to the model, to the engine, and try to predict. No, it will do in batches, right? So batch size cannot be smaller than your data number of samples. Now this part is your evaluation part. So what X test, Y test. This is just for information purpose. So if you just run now, this may take some time. So did anyone try to run this? So what can you see? Everyone can see those layers. Oh, nearby sir already done this. Code running. So it will take some time. See, we have reduced this data this much. I mean, we have got 32 by 32 pixels. Still, I mean, you can see the amount of time it is taking even on Colab, right? So you can imagine the computation power we will need. 78. Okay. All right. So we did with how many layers? We can try and okay, we'll do that. Let my output also. Yeah, you might get some differences, not much, but it is somewhere point. It won't be a much, like 1% here and there. So if what we can do here is we can try to maximize. Like, okay, so we in how many layer we did. I'll wait for my output to see how much I get. So we have got layer. So we have done convolution, we have got normalization, we have done coding, we have done how many layers? 4 layers, right? So we'll try to add one layer, or one more thing which happens is our data tries to see. If you see somewhere it will be 90 also, but then again it will go down. See here it is 99 right now, because it is trying, sometimes it tries to overfit the data. And some which we can add is dropout. So dropout, if you know, is what you can say, is the number of, is the percentage try to drop. It will not try to literally learn everything, right? So if it tries, so if that is the case, it will only work with the data which is present in the training data set. It will not work with the data which it haven't seen any time. For new data, it will not work if it tries to overfit, right? So there should be always dropout. Okay. Okay, so I got 78.18. Right, so more or less, what Smita has got more. Did you change anything, Smita? Or All right, so let's try one thing. Yes, so it will vary because of randomness of the data. I mean, even if I try to run every time, I'll get something slight different data. It's not, it will not be same, right? Although I'm not sure why 79 is the only different one. Otherwise, we all got in 78, 63, 47. So this, in this machine learning, you will never get same data. Sorry, same accuracy every time, or everyone will not get same accuracy. It varies because of the nature of the data. If it is same, then it means it is literally over what you say, overfitting the data by line. So yes, we'll get slightly different output. I'll try something like, I'll add some dropout because I feel it is time. I've just added one dropout here. This layer, dense layer. Also, I'll try one. And then you have to run this and the following cell, right? So now I have run to see dropouts. I've got more layers now. So total parameters 4,71,000. Did anyone try changing and seeing what difference they get? Anyone trying with different layers or some changes, like trying to remove one layer and see? Any different output? Anyone? Anything new? Tried? Improvements? So I got 79 now, 79.16. but I have added one to drop out. Is it? Yeah, to drop out I added. Okay, what did you try? To drop out or something else? How many parameters can you see? Is it this 4781 and all? Okay, 25 bucks. Yeah, it was 25 only. Anything? What did you, which parameter you changed? Layers. This one. Did you add this dropout? Try this. Right? This is input. These are two hidden layers. So try to make this maybe 128 and see any improvement is there. Anyone else? Vandana or Vinita or Vaishnavi? Okay. Good. Okay, the digit is running. Anyone else is also running? Try. In neural network, this is like there's no, that is the difference between machine learning and neural networks, kind of like box. So you may need to try some, like add some layer, check if it gives, adding a hidden layer. What it happens is basically you use a neural network when you want to predict any non-linear data, right? So adding a layer helps you to understand or say analyze that non-linearity in your data, but you have less control in neural network. It gives fantastic outputs, but again you have to, like, there's no definite thing you can do. You can try adding a layer, say okay, dropout might give you an advantage, max pooling, or increase the convolution size. These are the things. So yeah, let's see if it's still running. Okay, I got 80.7. 79.5. Yeah. So the one I tried earlier, I got 82.3. I have just had pasted it. 82, 83 with that. Let's try that. You also need to see the total params and trainable params. Okay, so if it goes more, so earlier it was see 4 lakh something, not 4 lakh, 4 million. So now it is 2. So again, if it is 4, it will take more time, right? It's twice. Although the layers are more, but see, number of trainable total params and trainable params are less. So I expect this to be quicker than the last one. Okay, let's see. I think this one gave me earlier around 82, 83. So which is good. I mean, 80, somewhere around 80 is good accuracy for neural network. It should be. Okay, it's there, right? I just added a few layers, and these are the changes I'm doing. Rest everything will remain. So you just add those layers. Nothing much changes. So I've added this now. I've done 2-3 runs. I could see around 77, 78. And last time I got 80 point something. So this one I ran earlier. It was giving around 82, 82, 83. So I can paste, no problem. I'll just paste it. I'll just let it run in case you're trying to type it down. I'll paste that, no problem. Just let me paste. Chetan. So everyone knows why it is 782. Why is it 782? Any idea? Why does it say 782? Epoch is fine, right? Epoch we did 25, that is understood. But what is this 782 on 782? No idea? See, 82.67, I get this. So this is the maximum I was getting with this. So I pasted that code which I tried, which was around 82. I mean, points it will be some near only, like 5 or 82.2 or 7. So Indrajit, you can try this. The one I pasted now. You should get around 82, more than 82. And Dr. Chetna, so anyone who is trying.
Okay, sir, we will try.
Okay, okay. Yeah. Okay. Not hearing from Vismita, Vaishali, Vandana. They finished the code. Okay. So how many runs did you do, Vismita? Did you try 2, 3 times, or are you trying the last one which I sent? So whoever is using the last code which I sent. Okay. So whoever is trying, just let me know once it finishes, and you get around same, like around 82. You should get 82 or more, maybe, or less. Not less. Somewhere 81, 82 maximum. Should be more than 80. And again, you can get more. I mean, whenever you have time, or you want to do more, dig into that, you can always go ahead. Okay, you can always go ahead and then try some more things based on the knowledge, the sessions which you would be having on this coming week. So you may know something. Okay, so I can try this. Yes. So you can try something, and you might get around 90. You won't get like 95, but always you will get around 90 max to max. 90, 92 is good. The max to max 85 to 90 is a good one. If you get more than that, then again your model is over learning your data, which is not good. right? It should not be trying to buy hard. It should know to get the pattern. So hope so everyone selected the, should not be a problem. Everyone should have selected this connect to hosted runtime and not local, because if by mistake you click that, it will take forever on your system. Anyone reached to the output accuracy? Indrajit must have. Smita, how far? How many epochs? Okay, so anyone, Smita, Indrajit, Vaishali, or Vandana, anyone doing? Okay, still running. How far? Oh, you have to run the subsequent all the previous cells. Make sure you do that. Yeah, that is a problem with collab. If disconnected, then gone. All right, okay, understood. Yeah, that is a challenge here. I mean, if you go for big data set and your session is gone, all lost. I mean, collab you can go for bigger ones, but again, that is a challenge. So, and in your local system, you need to have very like high configuration GPU and everything to run that. So that is a bigger challenge. Okay, if anyone of you reaches there, I'll just continue because it will remain same. Yeah, and I explain the later part. Still 14. Okay. Did you have to run all over again, Indrajit? It was 14. It's been a while. Okay. Sorry. Amnesty one, how big was it? I mean, was it not? You must have had similar issues there as well, isn't it? When you was it quick? Mhm. Yes, yes, it does. Yes, I know. But yeah, I was just trying to check how much improvement we are getting. I could do only if I added to when I added to Dr. Chetan. Yeah, but but the time it would be more than always more than two. In real life applications, they would always add more. Is there? So I mean, they doing POCs or just research. In that case, they might be less, but in actually it is always more than that. So yes, dense layer I've added in all three. Let me check. Yes, so last one you need to have Actually, that's why it's taking more time. Yeah, because dense layer means it is trying to get more. That's what I tried because it was giving less accuracy. So if you add dense layer, it tries to capture, it gives more interconnectivity. This is reducing. If we decrease the learning rate, okay. Yes, because if you decrease the learning rate and you have epoch is fixed, then your date, your algorithm won't have converged by the time your epoch is reached. It should be just optimum actually. Even if you do more learning rate, then also it will be a problem. You need to find an optimum one, because if you decrease means it is learning slowly. I mean, for an error of 100, you are changing only 1, 8.01. So if there is an error of 100, you are changing 0.01. Okay, so imagine the amount of time it will take to converge. So if you further decrease it, yes. So if you further decrease it, what will happen? It will converge very slow, right? Gradient descent you must have learned in earlier sessions. So learning rate, that should be like optimum. Yes. So if it goes more, you will not be able to find the minimum value. You can't go to the bottom, right? It's like bottom of the data type. And if it is less, you will go to the minimum, but it will take more time and more computation. So yeah, learning rate we can do, and in fact we can do one more thing. We try more epochs and less layers. Actually, this dense, I would say, because of the dense, I've added 3 dense layer. Actually, this would be there. Because output, it gives more input from every layer will go to each and every input in this layer. So that way it might capture more information. So that was the plan. But yeah, but it is computationally very expensive, quite expensive. I mean, comparatively. So how many epoch? Okay, go with 50, with 100, 50. You can give a try. But be sure to reduce these layers. Okay, at least two of them. These two. You can keep and these two calculation and this dense. Remove this and try to. I mean, in fact, epoch also should not be more. Again, that is again going to. If your data is not much, if you got more epoch, again it will overlearn. Right? So you may see your accuracy maybe very much high, like 98, 97. Again, that is not correct. Okay, so I believe most of someone of you have run this somewhere around 80. Someone क्या कर सकते हैं? क्या कर- Oh, did you start it? Oh, anyone else? Okay. So I'll maybe continue because then yeah. So again, this next line is just I'll just explain till then. So this line is I've given a name 82.2. Oh, good, good, good. So you got 82, right? So most of you should get around 82. Okay, 30 box. Okay. All right. So hold on for there, Vaishali, because again, if you start again, it will take a while. So maybe I'll explain later part, and then you can again you can give a try. 2.25. This accuracy is not increasing for 25 points. It is not increasing. So did you get 82 or not? On 25 you got 82 2.25, right? Okay, so what you mentioned saying it's not increasing for 25 points. So yeah, on 25 itself, I also got 82. Vaishali, I think tried with 30. Okay, so this I was just saying model path. Okay, model path. I want to save this model. I think this is inside the model. If you try to print, okay, if you just print the variable model, so it's basically a model is present. I don't know if you can do anything with that. So it has all now trying for 30. Okay, all right. So Chetna, you can go ahead and try removing the dense layer actually. Okay, because yeah, that might fasten up. Yeah, that might speed up the process. And just try to remove one dense layer out of it, because yeah, dense layer is computationally a bit expensive, but we get good output from it. So yeah, that's what I was adding, giving a try. Okay, yeah. So if you go for more epoch, you can try reducing the layers. I mean, try dense one. So try removing dense ones, because yeah, that will make it faster for you, because again you have to wait else, right? So go for 30 or 40, 45 epochs. It's good. So in mean later part. So I just got model path is the path where I want to save it, right? It's my model file which I want to save. So I'll just save it to a model path, because I want it later for prediction. Okay. So model.save will save this model, whichever I did. So if you just try to print model.summary or model, if you just say model, you will see it prints rest of something, right? So but you need something out of it. So also if you want to see what all methods are available, just do a dir, right? Meanwhile, while it is running, you can just, for whomever it is running, meanwhile you can then you can continue. So yes, so model, see you got these many methods. You can always go ahead and check what do they do. So if I'm just trying to see what is my model, so what does it have? So it has got some, it has learned something. It has got these many parameters, right? Trainable parameters. These many layers, these many parameters. Right. So okay, now if I run this, is saving. It should save model dot py, whatever this is, py file, right? Now then later we need to go to prediction. What prediction part, and also at the bottom we have this now predicting from webcam. That we can't run on Colab, so I'll let you know what you can do for that. So can I go to anyone ready running? I think Indrajit was, or I think Chetna, Dr. Chetna was still running. Vaishali. Vaishali is there, right? Vaishali, you have finished, right? You are with me. Okay, good. 83 when okay. So yeah, it is a bit improving on that. Okay. So yeah, later on try 40 or 50. Might you 30 it's 82. 30 it's 82. 83. Okay. Yeah. So yeah, for now just try hold on. because yeah, we can try again later on different combinations. Okay, so the model part, I just this is just 2 lines trying to save my model, because again I can use it for protection, right? You know, right? Once we create a model, we don't need to again always create it again and again. We can save it to a pickle file, or say model file h5. In this case, it is h5. Okay, so you can save it and then again use it for prediction later on, right? So that's why I'm saving, because I may need it for later. So coming over here, first line you see labels. So these labels, so it has got 9 labels, like 0 to refer to, we don't know, right? So they only have given the beginning of which they have CIFAR, right? So they have given like what does each of them mean? 0 airplane, automobile, bird, right? So based on that, we created a label text, basically created label text. We don't want to see numbers, right? We don't understand what does 0 mean, what does the 0 prediction would mean, right? So that is what we did here, labels. Now load model is the Keras method, where you just need to specify the path where you have saved, right? This model file you have saved. Now it can read that model file and start predicting. Okay. Right. So I'll just try run it. If it runs for me, or does it run? Okay, so I've got lots of output. So I'll go line by line now. So again, I've done this load data, although you may not need it, but I had different variables, so that's why I have done it. Okay. So all I need now is test data, x test and y test. So I've printed the shape of the training, everything. This may not be needed. Okay, this is just for debug purpose. So ignore this. This is not important. This is not, because all we need is x test and y test. We may have from, where is it? Here. X test we already have, right? Now if go there, so this is just x test, y test, and printing the number of rows present or shape of this method is. So if you know, we have done scale down of our image variables, or you say vectors, right? It was divided by 255 for the data. See, we did it. So for test also we need to follow the same process, right? Then only it can predict. It will be a altogether different thing, right? Because this is all in 0 and 1, 0 point, and then again suddenly it will start 200 to 55 values. It will not, right? So I created this method. Okay, so again this type float 32, and this is division, and we dot reshape. So again now my model needs data in the form as, initially it was, this is my data, 32, 32, right? So when I only one, so what will it give me? Like this, but my model is expecting in this format, so it will not work. That's why I have to do this reshape thing. So x test, when I say x test, right? So what does it have? So if I just print the shape, see 10,000 32, 33, this is fine. But if I try to say, okay, pick one row and try to predict for that row. Okay, say 0. Then I print the shape. So what is this? Now this becomes 3-dimensional. But it is expecting 4. Okay, so if you give this data, if you give the data as it is to your predict, where is it? Model.predict, it will not work. It will give you error. Right? So what you have to do is make sure it is on the same shape. So 32, 32, 33. So this is always fixed because your data was by 32 by 32 pixels and RGB 3 channels. Right? So this is one row out of that. So 0 into this. So it will create all zeros and then add this data there. It's just making sure you have converted it. Right? So then this is going to plot your figure. This is right or mistake means correct or incorrect. Okay, I am printing only 100, first 100 and predicting for only 100. Okay, indexes, pick a random index, right? Pick a random index from the text file and then get the text from that index. For example, I got 10,000, right? So I can pick like 900 or 1 or 10,000 itself, right? So I want to get that value and then I'll predict for that because I don't want to predict serially, right? So that's why if I run every time I will get different output. So now if I get this automobile and everything, I'll get, if I run again, I'll get something different. At least sequence would be different. See now, definitely. So here is horse now, right? So this is the use of this random thing. This is just plotting 10 row, 10 columns, and this is the position, right? So you can see it's 100, right? So 1, 2, 3, 4, 5, 6, 7. So 10 by 10, and then I plus 1 is the position which you are plotting. Right? So now this is the part, model.predict. So one at a time. And I'm passing the data, saying batch size one at a time. And then RAT is my prediction. So now for n in this. So okay, one more thing. Did everyone try to run this? Everyone got these pictures? Not. Just try running it first. Got it? Got the output? Okay, Vaishali got, Digit got yes. Okay, and who else was there? Vismita was there. Yeah, so everyone must have got, right? So about just what is it doing? Yes. So why did I say for n in 0 to 9? Because I've got 9 labels. So 80%. Okay. Much I got? You got 80%, I got 85. Yes. There might be slight here and there. I mean, if I run multiple time, I might also get something different because again, it will not predict 74. What was the accuracy, Dr. Chetman, for you? I mean, you ran again, right? Or 30 or 40 box. 82. Okay. So okay, try 1, 2, 3 times. Check if it is changing for you because 85 for me, I think something around 80. Vaishali also got. Let me try run again. If it changes because it will not predict the data exactly. Right? It will. will change because it is picking random test data. Okay, 82.37. All right. Any quicker? Should be quicker or not? Was it, Dr. Chetan? Actually, just try. Okay, I think we can add those 2 lines where you check the execution time, right? Just try adding those 2 lines. It will be useful to check like this. I say it's active, we should get I'm getting for this. Everyone ran that, right? Yeah, then only we will be able to run this. Save one, everyone should have run, right? 88% now. Okay. So it may be here and there because I told you this is random. It's picking random test data. It's not picking same test data every time. So some of them it will be able to predict perfectly. Some of them it may not be. Okay. So to deer means it predicted airplane, but it is a deer. So that's why it's a airplane not equals to deer. Wherever there is black, it is fine. Wherever it is red, you can say cat not equals to dog means the left part is the predicted one and the right one is the actual one. So there is red marked on that. So cat not equal to dog, cat not equal to truck. They predicted cat. Okay, this much. It's below. Yeah. So title is above. Yes, just below. So yeah, so I was here. So for n in I checked in labels and then if this is less than because it is giving you float, right? So if it is less than so I print this prediction. So you'll not get one prediction, you'll get multiple. You get full array for everything, right? You know that. Okay, fine. 88 is good. Actually, anything above 80, 82 is fine. It would maybe like slightly here and it will be. Okay. So if you know whenever you predict for the classification, since I have this dense layer, it will try to predict for every label, right? So see, so 0.945. So this is the biggest one. So it will be arranged in that order. So we'll try to pick up the maximum one and then assign that label, right? Because it will give for every, try to predict for each and every label. So we need to pick the one which is highest in probability. That's why I say best class equals to n. N means the number. Number is what? Label. So if y test of index it is equals to n, then pick the labels from the corresponding label. For example, this was 8. So pick that label from here and accordingly. So this part just prints tries to find the prediction we already get. in as an array. Okay, all you need to do is map it accordingly. So okay, all this, so this pretty output. So this way it will predict for, yeah. So you always get an array of 9 labels. This was it. So everyone must have got this output where it is wrong and right, right? So Vaishali only got, sorry, Dr. Chit got 88, yeah. So Vaishali was trying, and who else? Indrajit got 74. Who else? Did anyone else try? They, so there is also a code below that, but the thing is, we can't run it from Colab because it needs. I mean, predicting from webcam is what it says, right? So if you want to predict, I mean, you can use your webcam and try to predict any of those. If you, for example, like on your mobile, if you show a picture of say car or horse and check and see if it is able to predict, right? So this part is just extra code which just added because it was not working. My webcam was not working. But anyways, from Colab you can't access directly your webcam, right? So this code is exactly same as in prediction part because the model is already created. All you need to do is predict, right? And added few lines for reading from the camera. That's it. Rest everything will remain same. Okay. Yeah. So this part will be extra where you need to resize it because we are expecting a image of size 32 by 32. But depending on your resolution of the webcam, it will be a bigger image or higher resolution image. So that would be, you need to resize it and send it for prediction. Right, rest everything will be same. It will pick, see this code, everything is same, nothing is changed. Everything remains same. Just this is reading. Yeah. Okay. So, right. I mean, you can always give me a ping or say drop an email. I mean, if you try to run the part and if you have any queries or any issues, right? You can give me drop me an email. So yeah. So hope everyone is getting got the output. I mean, it would be somewhere more or less 80. Only Indrajit got 74. Try one more time maybe. A different set or variables. Yes, I think even Vaishali got 80 and Dr. Chetna got and Smita also got, I think. Right? Okay, any more queries? Any queries or anything? We'll put accuracy. Uh, and it will not, it should, since are running the cells here. Where are you running? You running that on your system? Not, you can't run on Colab. The previous question, how to report it? So you cannot. I mean, we predict exact accuracy. You normally what we do is we run a number of cases. Say for example, 10 or 20 samples, and then we create calculate average of it. So we say we get an we are getting an accuracy of about this much. It's not say we are getting accuracy of this much only. So it's about, we always say that, and we normally take an average because we can't. It's very difficult to say exactly this because not always right. It's because of the data. If you because of the randomness of the data, it will be slightly deviating. So it's always better just do more number of runs and do an average. It will not be drastically different. Like it will not be like 80 and 60. It will never be right. It will be around plus or minus 5 max to max. Great. Average, or there are different ways of measuring it, like average, mean, all the statistical terms you can do, depends how you want to report it. But yeah, it's not always one run, it's across the runs, because then you know it is more of stable. If you're getting 60 and 80, then you know something is wrong. It's not, the model is not correct. It's not giving proper accuracy. It's drastically changing. So that's how it is. Yeah. So Vismita was saying, yeah, Vismita, you have to copy this code based on your local, but before that you need to make sure. Okay, one more thing, sorry. You need to make sure you have this file. You'll be having this file, right? H5 model file. Anyone who made, yes. Yeah, Dr. Chitni, correct. So, Vismita, you are trying to run it from local system. Before that, just make sure you download this file, right? Because this is our model file. Getting anyone who will be trying to run this, just make sure to download. Make sure to download the slide over here as well. Yeah, I have written over here. This also. Okay, that's it for now. I mean, unless anyone has any question or anyone is trying something or getting stuck or something.
Yes, anyone is having any doubt? Someone was speaking?
No, I think no.
Okay, I thought. Okay, thank you so much, sir, for giving this hands-on on object detection using CN. The way you have conducted and with the pace that you have gone through, and you have made each and every participant to perform hands-on with you. So thank you so much, sir, for this. Sir, shall I share my screen?
Yeah, you can. I mean, I've just shared my email ID as well in case anyone having any issues or you want to do something more. Like the last part I just given just for just for the fun. If it's someone want to do anything, so if anyone have any queries or want to do more use cases something, so they can always reach me out. They can drop me an email and then yeah, I can help because I also do many things. This one was I used this use case because we have time constraint and all that thing. So there are advanced one as well. So if anyone is interested, so you can, all right.
Yes, sir. Sure.
Yeah, you can share.
So, sir, please accept this virtual memento on behalf of the organizing committee. Thank you, sir.
Okay, thank you. Thanks a lot. Thanks everyone.
Thank you, Pankaj sir. Thank you very much.
Yeah, thank you.
Yeah. Okay. I just got disconnected 5 minutes ago. So I have to restart the network.
Okay.
Yeah. Soni madam,
Yeah.
Yes, sir. Yes, sir.
meet Monday morning, right? Is not shared here. She might have joined
Yeah.
once again.
Yeah, I'll just do.